Okay. Now, what is this about? The laminar sublayer thickness. You remember when we are talking about this boundary layer thickness, you start with the leading edge where x is equal to 0, right? Y equal to 0. You start with this, then it growing, it become turbulent. But even in this turbulent, we still have a sublayer which is laminar. So this is it. Okay. So if you want to calculate the laminar sublayer thickness, you can use the equation. If the surface is the surface is considered to be hydrodynamically smooth if your K, which is the roughness, surface roughness, you get it from the data. For galvanized steel, it will be 0.015 millimeters. Okay, if that divided by your dose thing is less than 0.25, then it's considered to be smooth. Okay, so you bring your Myvi or Viva, you do not want to meet me, you do not want to see the class, so you run away. Then you go through the jalan, via Jalan Lahat. You know Jalan Lahat and Jalan Pasir Putih this time will be damn jam. So you are trapped in a heavy traffic at speed of 18 km per hour. Yeah, it's normal when you have a jam. Right? This is Ipoh, very hot. So you are trapped in a hot day. Okay, for that condition, the kinematic viscosity of the air is 1.6 times 10 to the power of minus 5, right? You assume the hood of the car is 1.2 meters. Okay. To be honest, actually the hood of the car is not flat plate, right? It's a little bit of curve, but you can take the approach, take an assumption that the hood is a flat plate. Okay, so basically I should not put that, but put the old Saga. You know, the old Saga has a flat bonnet, right? So I can put the old Saga Ato, put there, then it will be better. So now you need to change the speed from kilometer per hour into meter per second. You do that, you get your U is 5 meter per second. The question is, what is the boundary layer thickness at the end of the hood, which is near your windscreen? At the end of the hood, right? Approaching your windscreen, what is the delta? So, you know your velocity, now you can calculate your Reynolds number, okay? By looking at the Reynolds number, you can guess, is it laminar or turbulent? Turbulent. Good. You did not read. Put there, laminar. The critical Reynolds number is 500,000. So if it is less than that, of course you have a fully laminar flow, right? Since you have a laminar flow, again I make a mistake here. It's supposed to be 4.91. 4.1 will be different little bit. Okay, so you find that at the end of the hood, the boundary layer thickness will be 9.79. Okay, the next question I can ask to you is, what is the shear stress working on the hood? Yeah, you need to find the coefficient of friction. Once you get your coefficient of friction, you can calculate your shear stress. When you calculate your shear stress, if you know the area, you can calculate the force. The force times the velocity, you get the power. Okay? So basically, in this external flow, you will know how much power is needed to overcome the fluid friction. Okay? So if you can calculate the friction exerted by the tire, okay, so if you combine dynamics and fluid mechanics, you can design how much power is needed to drive your car. Because you know the rolling friction. Once you calculate the rolling friction, you calculate the air friction. You combine those, you will get the power needed to propel your car, to drive your car. Okay, one more thing. Because of this boundary layer thickness, okay, for the fluid that is far away from the wall, okay, they feel, the fluid feel that the wall is getting closer to them. You know, like it is not real. Along the way, you feel like your friend is closer to you. You feel, while in fact it is not. Right? Rasanya. Right? You feel that he's closing to you. No, it's just apparently it is like that. So, due to the boundary layer there, the apparent thickness of the wall is increased as you go further. Okay, so this is your real wall, this is the actual wall, but for the fluid far away, this is the apparent wall. Okay, it is not the real wall. Apparently, this is the wall. So they look at it, they say, oh, why the wall is closer to me now? Okay, so what is the effect of this? Because of this apparent wall, of course, now your flow will behave differently, right? Rather than following the exact wall, because the wall gives you the no slip condition. So this apparent wall, now you have the wall over there. Okay? This will affect when you have a wind tunnel test. You have wind tunnel test, you have the section test there. You have a big tunnel, then becomes small, goes into that, and dispatch again. Okay, there is a reason why you do that. Okay, because you want to get the flow to be uniform. You want to mimic the uniformness of that. That's why you got those big things. It is not there just for fun. Right? It is not there to suck you. Because it's big, you can put your hair there. No. It is there to help the flow with the profile. Okay? So, the problem with this is that your boundary layer development will be much faster compared to this condition. This is the ideal condition, that is the real condition. Because there is an apparent wall growing. So, you see this one getting closer. So it will become fully developed faster, right?